daily problems. The date is 9/23. This is the LeetCode daily problem, simple and easy. Binary tree, pre-order traversal. Do I need to explain it? This is just a standard pre-order traversal. You have given a binary tree, and then you have to return the pre-order traversal in a vector format. You know what is pre-order traversal? First node, then goes to left, then go to right. So first you'll print 1, which is your node. Left is nothing, so move to right. You'll print 2. Not 2, basically now 2 becomes your root. And you print your root first. You print 2 first. Then you print your left part, which is 3. Then you print your right part, which is nothing over here. But that's about it. Pre-order is this root left right. In order is left for root, then right. And post order is left right and then root. For example, if I had to write post order for this, what would it be? First, I will say what is present in my left. Nothing. What is present on my right? Move to this. So 2 will say what is present on your left. 3. So first of all, first thing which I'm gonna write over here is would be 3. If I do post or traversal, right? 3. Then I would write nothing because right is nothing. Then I'll write 2 and then I'll write 1. So how post or traversal looks like? Just if I remove this from here, do this and write it over here. Let's see what the answer comes out. It should come out 3 to 1, right? That is the post or traversal. And this is the in order traversal. If you have to write between these two function call, you can write v dot push back, then it will give you in order. For this, what will be in order? Left, then root, then right. So 1, then 3, then 2, right? That's in order. And if you write to do pre-order, it's simple that you first include your root node into the vector, then call on your left and then call on your right. If you reach the null node, you can just return and just return the vector. That's about it all. Let's give it a submit. These 5 lines of code. Okay, I created a vector over here. You can create it inside the function calls only if you don't want to use external, uh, global variables. V, V, not V just, but vector dot int and pass V, and you can pass V over here as well. Let's try this. It should work, right? Just vector is getting updated every time. Okay, 100 time 100% fast. So that's about it. Let's move to GFG problem of the day, last modified ball. This was also again pretty simple and easy problem as you can see, but yeah, that's about it. So you have been given n balls, bowl, and in straight line present, and few marbles which are randomly in each eyeball. Okay, so ith ball has AI marbles. It can be anything. And the marble can never have more than 9 marbles. That is a constraint. This AI is less than 9 or equal to 9 for sure. The ball can have 0 marbles. Okay, so any ball can have 0 marble also. Now Samuel's friend adds one more marble to the last ball. Now you are adding the marble to the last ball. There is two cases. If the ball is completely filled, you cannot add. If it is not completely full, you can add in the last one, and your last one ball will be get updated to something like x to x plus 1, but it cannot move from 9 to 10. So what will happen after this addition of ball must be still aligned with the rules. Rules are that every ball should contain at most 3 no, sorry 9. So if you already have nines in the last bowl, you cannot, if you push the new marble into that, one marble is gonna pop out and will go to the second last ball. So now the last will only contain 9, the second last will get updated by plus 1, and so on. If second last is also filled, then third last will be get updated. So that is. And adding a new marbles following the same rule, addition of carryover. This is the rule of carryover. If your nth one is filled, let's say this is something and 9 is present over here, and you try to add plus 1 more marble, so it will not go into this, it will not make 9 10, it will remain 9. Let's say over here 6 was returned, so 6 will get updated and 6 will get 7 now. One carryover will come from the last. Yeah, you are given initial list, and below the positions which are modified, guarantee that there is at least one ball. Okay, so there is guarantee that it's not possible like everyone is 9999. because in that case if you add plus one, he will say okay, let's try to shift in this one, and he'll say okay, I'm full, let's try to shift in over this one, this is also full, and you don't have extra ball. Now one plus one marble falls out from the first place. That's not gonna happen. It will at least go into any one of the balls. So this will be one or something like that, right? Okay, anything, but just one space would be left at least. And that's what you have to do. You have to return the index where the new marble will go, right? Find the position of the ball last modified. Okay, position of the ball that is lastly modified, not where the marble will go. I'm explaining the question a bit because this is nothing in the solution. You just have to carry forward your previous marble to the next ball if the previous one was overflowing. In this case, previous one, last one is 5, so not overflow. You just return 4, which is the index of this. For this, 9 will carry forward over this. This 9 will carry over this. Down this position will get updated to 2. So last updation is I, which is 1. If you say 1 based indexing. So that's what I did. Should I write it again? It's simple. Like you just started from the last index, check whether it's completely filled or not. If it is lesser than 9, means there are space, then you will say okay, it's bus. It will not move to. There will be no carry forward. Okay, and you can return the I plus 1, which is the index. Otherwise, you still go on this loop, n minus 1, then n minus 2, and then minus 3. Anyone should be less than 9, right? Or the first of all, the first one which you get 9, less than 9 is your answer. That index your answer. So I plus 1 for that. And if you don't find any answer, return 0, but that's not possible. So you can write anything over here because that's not gonna returning anyway because the answer is always possible. They have said it. So you can try to just submit it. As you can see, test cases are also very less. So 121 test cases all got submitted. And that's about it. I don't know what this topic was. It's just like just a for loop iteration checking number less than 9. Okay, guys, that's about it. Bye.